Hi everyone, welcome to my YouTube channel Tech Data Engineer. So today we will see with a simple example. We have taken an example like reading data from CSV, doing some transformations, and then writing back the transformation data into the CSV file. Okay, so today we will see the one of the most I can say used principle in software designing, that is solid principle. So today we will see what is solid principle and how to implement that in you can say object oriented and basically in pyspark related job. Okay, so how we can implement that and all. Okay, with a simple example, first we will see what is solid principle, and then we will see step by step the I can say step like how we are reading the data, like what is the desired transformation we are applying, and how we are writing data back to the CSV file. Okay, so let us consider first what is solid principle. So basically solid principle are a set of design principle that is basically intended to make software design more understandable, flexible and maintainable. Okay, so why we are if we are building any you can say project, so why we are maintaining solid principle? Because of it because of it's understandable, flexible and maintainable. Okay, so solid principle basically meant for object oriented programming. Their concept can be applied to various programming paradigm including pyspark also. So solid principle applied where there is a object oriented programming. So and then we can extend up in pyspark also, which is basically a big data processing. Okay, so let us see an example. So in this example what we are doing, basically we are reading the data from CSV, performing design transformation and writing the transport data back to CSV. Okay, so in solid what is the abbreviations of solid is basically it's for single responsibility principle, that is called SRP. And then it's come to O stand for open closed principle, and L stands for Lisco substitutions principle, and I stands for interface segregation principle, D stands for dependency inversion principle. Okay, so solid have the abbreviations like that. We will see each one of the things in details, and we'll see how we have implemented this all. Okay, so first we'll talk about the S stands for single responsibility principle. So what basically it tells, each function or class have only one reason to change, meaning it should only have one job or responsibility. Okay, so what it means basically, so it want to say that like for each functions, okay, each functions or class should have only one reason to change. Okay, so in PySpark applications you should adhere to SRP. SRP means single responsibility, separating the responsibilities of reading data. So suppose we have the reading data, then transforming data and writing data into the distinct function or classes. So reading data, like create a function or class method dedicated to reading CSV. So single responsibility tells that for each function or class there should have only one region to change, means for each functionality there should be only one data frame or class, only one module or class. Okay, sorry for that. So one region to change. So that's why for reading the data there should be one class or one module, and then therefore one module means one functions, and for performance transformations there should be one functions, and then writing back there should be one function. So that basically tells about that. Okay, so here we will see first what we are doing. We are just from PySpark the SQL we are importing the Spark session, then we are extracting the call and expressions, then we are creating a Spark session as named as CSV transformation. Then we have defined three functions in our example. first reading the data from CSV, we are giving the file path, and then returning the data frame. So we are returning as a spark dot read CSV file path, header and info schema. And then what we are doing, we are doing some transformations. In transformation functions, we are taking as a data frame and returning again as a data frame. So what we are doing, we are doing three transformation. One is the adding new column to the with a derived value. So just this is a simple example, you can take any example with your own. So what basically we are doing, we are doing def dot with column, we are taking new column, and what we are doing, we are multiplying with the existing column with the 2, and where we are appending into the new column. That is a simple transformation. Then again we are renaming whatever the existing name we have, we are just renaming old column name to new column name. Similar way, third transformations what we are doing, with df dot filter column equals to some name. If value is greater than 100, then we are taking that, we are filtering based on that. Then fourth would be unwanted column. Suppose you wanted to delete unwanted, so df dot drop, and then we can pass the unwanted column and returning the df. So this is one functions for reading the CSV, others for transforming DF. So it is basically so our code is basically following the single responsibility principle. Again, a similar way for writing into CSV, we have defined a functions, define write CSV. Okay, so that what basically doing, it is taking as a data frame and writing back to the path, like CSV file path. So we will pass a path, and this taking input as a transform def, and we are restoring to the output file path. Okay, then the code would be df dot write csv output path header equals to true and mode is override. So while writing the data to csv, what we are doing, we are taking mode as a override. We can do it append or anything, or error mode or something based on your convenience where you wanted to do that. Then again we have main functions, which is taking its input path as a string, output path also a string. But basically it is doing, it is reading csv, transforming df, and this is basically a data frame. This is one data frame for reading csv, transform data frame, and writing csv. It's like transform df, and output path it is basically taking. And then we have equals to name equals to main. Then but basically based on input output file, it will running the main file. So as we have seen, so I have explained the code. So as we have seen by the first principle, single responsibility, it is basically for each functions or class there have only one region to change. So we have, that's why we have created the three classes or three functions, you can say, reading, transforming, and third would be the writing. If there is other logic also, if other task also we have to perform, we can create a different functions or different class based on that. Then it will follow the single responsibility principle. Now come back to the open closed principle. So what it means, basically software entity should be open for extension but closed for modification. So what basically it mean, if you are adding some new functionality to your code, so there should not be any change with your in any modification with your older functionality or older code. Okay, you can add some new code in that, but you can't change. So now come to the our example here in transform da. Suppose we wanted some new can say transformation to be added, so we don't have to change with the existing one, we can add the new one. So this code will follow open closed principle also. Okay, so so in pyspark you should use this principle by designing your transformation functions to be extensible. Okay, you might create a base transformation function and then other transformation functions also. Okay, so now our code is following these two principle, single responsibility, and other is open close. Now come to the third point, lisco substitution principle. So what it will basically, object or function should be replaceable with instance of their subtype without altering the correctness of the program. So I'll see, we will see what we are doing basically here. And then fourth is the interface segregation principle, ISP. What it tell, basically client should not be forced to depend on the interface they do not use. Okay, and the fifth one is the dependency inversion principle, like high level module should not depend on low level module. both should depend on abstraction. Like abstraction should not depend on details, and details should not depend on abstraction. So what it means, I'll explain that also. Okay, so what it means basically, so we have already seen in our code that, like first principle, so first principle is like a single responsibility principle. Like each functions read CSP, transform data, write CSP main has a single well defined responsibility. Okay, now this is clear. Other one was open closed principle. So in our code, the code can be extended with the new transformations without modifying the existing function. For example, so in our code, adding to the new transformation in transform data. So in transform data, adding to the new transformation does not require to change the other functions. Okay, so that is also correct. Now come to the Lisco substitution principle. So the functions work with a data frame object as input and output, ensuring that data frame object can be used interchangeably. So that also we are doing in our case, like we are using the data frame as a interchangeably for our, you can say, functions. So that is also following that. Now fourth one is the interface segregation principle. So in that case, function have clear interface as input and output parameter are not forced to implement method they don't use. So in our case also, what we are doing, we are passing the input and output parameter. So where there is no use, it is not required to implement that particular, you can say, method. Okay, so where in the method, if that is not required input and output parameter, so like, so there should not be any force to implement method they don't use. Okay, so that also we are doing wherever it is required, it is we are doing in that. Now fourth one is the dependency inversion principle. So in our case, high level modules, something like main. Okay, high level module main functions depend on abstractions of like data frame. Okay, not on the low level CSP for handling. So in our case, what is happening, dependency inversion principle means like, it's like high level module, in our case main, depends on abstractions like on data frame, not on the CSV file. Okay, so with this simple example, I have written in a code such a way that this will follow our solid principle. So similar to that also, you can, for any task whatever required in big data processing, you can follow this principle at that instance. Like you can follow each line and try to implement your code based on this solid principle. Okay, so again here also it's initialization, reading CSP, write transformations, and writing CSP then main function and entry checkpoint. Here also I have written that solid principle. It's like for each function have the single functionality similar to read CSP, transform data, write CSV, and main all have the different functionality. So they have different responsibility. Open closed also we have already done that the code can be extended with a new transformation without it. So we have in transformation data, we have different functional different implementations, so we can add some new implementation without changing that. Similar to Lisco substitution principle also, like function work with the data frame object as input and output also. So I have already explained this all the point also, so please check that. Based on this our code, our basically this code is following the solid principle. So that's, I have already explained the solid principle what it means. So please check that and design your code such a way that it will follow the means asked conditions for this solid principle. Okay, thank you, thanks for watching.